So today, it was an extremely informal introduction to the usefulness of inheritance. We got exposed to some of the syntax, and we got this. We're actually came up with this possibility of having an object which is shared by all of them. So to complete this, we need to say that triangle has a rectangle box, which is basically horrible to say, but that's what we have by design. But inside, and let me switch to like a thicker pencil here. But inside there is also a shape inside of all of them. It's like little Russian dolls, right? One inside another, inside another, inside another. This is what we have created by using this type of inheritance. So inheritance diagrams are typically drawn like this. Is that there's shape, there is circle and rectangle, and they inherit from the shape. These are actually arrows with like those triangular pointers at the base class end. And then we also created a triangle, strangely deriving it from the rectangle. So this is shape, this is circle, this is rectangle, and this is triangle. So this is how inheritance diagrams are drawn. You can basically display the inheritance diagram. So let's use Google to say switch to image search and say C++ inheritance diagram. Right. So do the search. So see, there you go. All kind of diagrams showing how much inheritance is there. So let's take a closer look. There's a diagram that says exception base, the top of the hierarchy. From it we derive connection exception, data modified exception, whatever those things are, right? Folder not exist exception, also deriving. From the severe error exception, we derive bad input, connection timeout, internal error, and so forth. So that's an interesting example of this. Oh, I just closed this tab. But you get the idea that this is something that what we do. I'm trying to find the right spot here, maybe just looking at the code or this. That essentially, first, maybe we should not think of our environments as some sort of inherited structures. Rather, what happens is we identify objects that can be useful in our application. And we say, let's have class circle, rectangle, other types of objects. Like in the world of 3D drawing, I could say that I would like to draw trees and buildings, and I would like to be able to draw individual characters, cars, and other objects in my virtual world, right? So first I come up with useful concepts, right? I say, okay, we should have all these classes in our application. But then I say, well, you know what? They're all drawable. They're all part of the geometry of my virtual world if I want to visualize it. So there's something in common. And it's kind of like I could circle it around to say, okay, these all belong to the same part. But there's this formal way of doing it, like, okay, maybe it's a drawable object, and you can create this class dedicated to the drawable object and make it an interface and have these guys inherit from there. Then guess what? We can instantiate those, keep track of them, but use this interface to talk to our individual objects. So next week we're going to discuss how does C++ provide this functionality, why we had to use new, right? Why is it that we have to use pointers to our classes when we deal with this polymorphic behavior? And of course, we need to discuss what other possibilities exist and what is this part, which makes it a pure virtual function. So we have to go through some technical details. So today it was a demonstration of how useful can it be, and inheritance becomes a design pattern or design which you can use in structuring your application. Right? So because things can have a lot of things in common, and therefore we can organize them not as a standalone objects, but objects which are related. And this relationship is expressed in C++, if that's the inheritance relationship, is through the syntax that other way to vocalize this is rectangle is a shape. Circle is a shape. And triangle is a rectangle, which is a horrible thing to say, but also because we already know that triangle is a rectangle, but rectangle is a shape, then obviously triangle is also a shape, which we try to demonstrate on this sort of like what this object looks like at runtime. So to be continued. Today we spent good portion of time working with these operators. I will post the sample we developed. I already saved it on my drive, so I will promise to post it tomorrow morning most likely. And this is to be continued next week. So that's it for today. Thank you guys. Have a good night.